Hello, everybody, and let's go into it. So, as you can see, we are live here in Cinetech Studio, and we are going to take a deep dive into the area of code generation. So, the presentation is divided into three main parts. First, we are going to see why is code generation useful in the first place, right? And we are also going to see a few examples of some well-established iOS and Android tools that use code generation that are commonly used today. Then we are going to see and look at how we can approach finding patterns in code. And as I will highlight in this section, finding or not finding patterns in code may be just a mindset issue. And finally, in section 3, I would like to introduce you to our open source tool called GenGen, and which was designed specifically to tackle some of the problems that we are facing as we were thinking about how we can generate more code in our project. And one quick note, you can get all the resources at cinetech.cz/mdevcamp2020.zip. And there might be a lot of new information, especially in the part 3. So please don't feel like you have to remember everything or anything, maybe just the core concepts, what GenGen can help you with. And everything else can be reviewed afterwards. The contents of the resources are this presentation, the GenGen tool, which is also clonable from our GitLab, and also the manual for the GenGen tool, so where everything should be explained quite clearly, I hope. And if you would happen to be in a situation that GenGen isn't doing what it should, you can always raise an issue on GitLab, or you can write me a message, and I will try do my best to help you with that problem. All right. So why should we like be interested in code generation, right? Well, probably the most obvious idea that may come to our minds is that more code is generated, the less code needs to be written. Yeah, and a good candidate for of code to be generated is this so-called boilerplate code. And just to be sure that we are on the same page as I'm talking about boilerplate code, let's try to stick with this semi-official definition that boilerplate code is a term that should describe sections of code that need to be included in many sections with many or no alternation, which I think is a nice definition. All right, so yeah, code generation can get you rid of this work of writing the boilerplate code. But I think there might be some rather hidden aspects of code generation which are not obvious until someone starts to think deeply about it. And the first thing is that when a team of developers begins to think, how can we generate more code, this can naturally lead to team discussion about useful convention. And of course, usually there are some guidelines like coding guidelines, which can be detailed in various extent. But here we are really talking about really detailed conventions that can make a lot of this boilerplate code generable. And there is also one nice side effect of this, and that is that setting up these detailed conventions can lead to an environment where you open any project in your company on the platform you specialize at, and it just feels like it was written by you. Sounds awesome, right? And well, it is also possible by setting the proper conventions. But there is a tax to pay for this. And this tax is especially high for people who might suffer of software egoism, and they might be convinced that they know how to do things the best. Well, there are always some better ways how to do things, and so this type of people may be challenged to step back from their egoism in order to be a proper team player and make this awesome environment where every project feels like it was written by you to be. And yeah, eventually this leads to another nice thing, because less egoism is usually related to less stress, less anger, and less fear, less dark side, basically, and more productivity, efficiency, and happiness. So this is really some sort of a positive feedback loop we observe here, and it gives us the ultimate answer for the question, why is code generation useful? And the answer is, code generation is useful because it makes people happy. And I know I may be a little exaggerating here, but think about it. I think there might be some nice idea in this seemingly silly train of thoughts. And once there are those nice conventions and every project feels natural and people are happy, everything just speeds up and the development process is more and more efficient thanks to code generation and thinking about code generation. Now, let's see a few nice examples of code generation tools we commonly use today. The first example is from the iOS world, and it's a nice tool created originally by Matthijs Kadijk called RSwift. And this tool does one thing and does it very well. It basically just creates Swift code for static resources. Things like images, fonts, strings, files, entitlements, settings bundles, etc. And yeah, there is this not safe way by gaining access to these resources, like using strings, which is really unsafe. But this tool makes it super safe and super reliable, and every change is reflected in the generated code. And yeah, basically, it deals with that issue in a very nice way. And yeah, it's code generation, well, analysis and code generation that makes this possible. Now, yeah, and everything is then, every static resource can be handled like this when using the tool. And Android developers probably see where the inspiration came from. Yeah, so thank you, Android world, for being such a nice inspiration for iOS world, and of course, vice versa. All right, speaking of Android, let's check one nice example from the Android world, and that is the retrofit library, which is defined as a type-safe HTTP client. And one thing that it does very well is handling networking calls to API endpoints. And all you need there, when you have the data class onto which the response should be mapped, when you have this defined, you just need to define the interface for the individual API calls. And the rest is generated. Now, yeah, you basically need something like this, which I think is pretty awesome. And if you have ever developed the networking layer with more low-level solutions like HTTP URL connection on Android or URL session in iOS, you can immediately see how much time this can save. All right, and I think there is one more example that takes this even one step further, and that is the Apollo client. Apollo Client isn't really a platform-specific tool. It is released for all the major platforms, and it does a very similar thing as Retrofit, but this time in communication with the GraphQL API server. And here, similarly to the Retrofit example, you just need a GraphQL request defined, and once the build passes, you can immediately call the request. You even have the response mapped to a Swift or Kotlin object. And another nice thing is that since the schema of the GraphQL server is available, the Apollo client checks if all the requests are written properly, and if not, you get immediately a warning, build fails, and you know that the request is badly defined. So that's a lot of nice things that Apollo client does, and a lot of things that are generated. And you basically need this, right? This is the GraphQL query. And then everything else you need to perform the queries and have its response mapped is generated. And yeah, as I'm thinking about it and speaking about it, I easily get speechless, because when I first saw this at work, it felt like a miracle to me. I even had tears in my eyes when I saw how much time can be saved by using such an awesome tool. And I believe that creating such awesome technologies is our call of duty, because we have also happened to be in a very lucrative area, business area, which is probably going to be stable for some time. And just to express the gratitude and thankfulness for this opportunity, I think creating such awesome technologies and making them open source is one of the proper ways how we can express this gratitude for this opportunity to work in this business area. So moving away from this personal ideological insertion into the presentation, there are many handy tools you can use that generate code in different sizes, like code snippets, templates, some nice plugins, and you can always write your nice little script that can be run as a custom build phase in Xcode or as a Gradle task in Android Studio. And we would probably be able to find many more if we would want to. All right, now that we might be at least a little interested in code generation, the first step that usually happens is that we need to find some patterns in code. And here, as I've somehow pointed earlier, this only might be a mindset issue, right? Because we should have proper mindset that we should be effectively, productively lazy, because I think this type of laziness is really what can make some super nice innovations. Well, in history it was war and laziness, so let's emphasize the laziness and try to get war out of the game. But that's not on us, but never mind. Let's be productively lazy and have the proper mindset. And what I like to emphasize here is that I've seen earlier that people easily get used to write things in certain way, like without even thinking about that there might be another solutions, another options how to write things. But there is always a better way. There's basically always a better way how to write things. This is why we created GenGen, and it is all about how lazy you actually are. Well, productively lazy. And the way I like to think about it is that anything that is written twice indicates either a missing abstraction or it's a boilerplate code. And then there is this issue with clean architecture, that cleaner it gets, it usually introduces more boilerplate code, which is a nice and not nice thing, essentially, but I will touch on that a little later. So let's take a look on a seemingly innocent example of boilerplate code, and that is this process of how data binding is done in Android, and in iOS is like almost the same thing, but with different syntax. So as you can see, this row, Android source, view model, transaction details, image resource, is somehow similar to this Android text, view model, transaction details, description, which is again quite similar to this Android text, view model, transaction details, transaction type. I think there is some boilerplate code going around here. And of course, there is this obligatory property in the view model towards which the individual views are mapped. And this might seem like a little thing, right? But how many times you did this? It can be hundreds of times, maybe even thousands. When there's a project, when new features are developed frequently, this can take hours, actually, especially when there are some crazy change requests from the customer and you need to make all the data bindings again and again and again. Yeah. So I think there's no need actually to write all of this, as we will see a little later. Now, stepping into the iOS world, there is a similar example with interaction binding, and this also applies to Android. And yeah, as I've said, Android data binding style applies to the iOS. It's like all boilerplate code. So here you see a function, again, an example how interaction with a view can be handled. And if you would look at two another buttons, oh my God, it's almost the same, right? Yeah, and once we have these functions nicely separated, we need to call them again in a nicely separated function. And this nicely separated function needs to be called again in, for example, in some sort of lifecycle method. And again, it's a one huge pattern, right? Well, to be fair, here is probably an example of missing abstraction, because if the project has something like this, a protocol that provides basic implementation for the bind functions, then the binding can be done like this. But still, do we have to write that? Really? I don't want to write that. No. So let's not write that, right? And we're going to see how in a little while. And yeah, the clean architecture is awesome. It makes people able to orientate themselves in projects with little information actually about the project, even cross-platform style. And it could be a huge helper when an Android developer wants to learn iOS, or vice versa. When there are projects with same architecture, it can be a huge helper because Android developer can immediately go into the iOS project, and thanks to the architectures being well, same or almost the same, this can really make it easy to understand what's going on. But as the architecture gets cleaner and concerns get more separated, the separation needs to be handled by some type of connection. And this connection is usually a lot of boilerplate code, which, yeah, again, do we want to write that? No, we definitely do not want to write that. But we were in this situation last year when we were developing the anonymous access module into the Oriflame app, which I think is a great module. We were doing this sort of boilerplate coding again and again and again and again and again without no end. So I just said, stop. We must do something with that. And so we did, and created GenGen. A little dramatic pause. Dramatic pause ends. So GenGen, also known as general generator, is a template-based, fully configurable code generator, which goal is to empower user to create a code generator for anything that the user might want to generate. Sounds nice, right? Well, it's very simple how the generator does that, because there are those templates, as we can see here, and what you can see on the left top-ish side, here is a simple template set that the generator operates with. And the arrows are pointing towards the contents of those files. And basically, we see all three types of files that the generator use. So the .swift file is like the root template, let's say. And as you can probably see, the parts delimited with the hash sign or number sign or pound sign are the placeholders. And the .config file is a configuration file that I will break down in a little while. And also there is this simple underscore subtemplate.txt, which is a subtemplate. And let's see how the generator processes that. But first, this is how the UI may look like, especially from the header value to the bottom. This is fully configurable, and you can set the input to look just the way you need and the templates need. At the top, probably everything should be pretty self-explanatory. The output there button makes you able to point to where the output should go. Show output opens the folder. Template library lets you point to the location where the template library is. Below it is the drop-down menu where you can select between the individual template sets, and the rest of it should be pretty self-explanatory. The tree view shows you all the input in a nice tree view. All right, so assuming we have input like this, and one quick note, all the examples that I will be showing are included in the resources, so if you want to try them yourself and play with it, you can do it just by getting the resources, which are, of course, free of charge. So the template does the processing like this. The header value, not surprisingly, replaces the header value placeholder in the template. And what you can see on the left bottom is the final output. And the rows are processed like this. So for every row, the simple underscore subtemplate txt contents are loaded and placed into the final output, while the row values are replacing the row value placeholder. So this is at the core. And as you will see later, there are some other options how to make this generation process more flexible more flexible. All right, so to give a more concrete example, let's see this example of iOS networking, which is our attempt to get closer to the retrofit style of writing networking layers. So here we can, the UI is probably pretty self-explanatory. The rows are representing the individual requests, where each request has to have a name. The endpoints have some path. The output, the response is mapped to some output type, and you can some HTTP method, and you can also check that the return type towards which the response is mapped is an array. And in the header, we have the networking type and base URL header fields. All right, so this is how the input might look like. It's basically the same thing as we have seen with the retrofit example. And when we click on generate, something like this happens. On the left, we see the template set, and on the right, we see the final output. So if we just go quickly through all the files from the abstract top, here we have the protocol specifying what the networking layer or networking layer component should provide. Here we have the implementation with prepared Moya provider, which is like the retrofit object, along with the base URL. And here is the extension of the implementation, making it conforming to the GitHub API protocol. And as you can see, we have both requests prepared to be called, and the response is going to be mapped onto the types that were specified in the input. And there are also these spec objects initialized, and those looks like this, which is basically the closer we could get. Maybe we could get even closer, but we're trying to get closer with this to the retrofit interface definition. And everything should be pretty prepared here. Only thing that needs to be done is to format the path string, and you can call the request. And in order to confirm that the requests are implemented properly, there are some unit tests also generated. And you can immediately try if the requests are doing what they should, or the calls are doing what they should. And may I tell you a little secret? Retrofit doesn't generate unit tests for you, but keep it to yourself, okay? Yeah, and the next files, this is just some Moya boilerplate code in more clean way, because if you have ever developed networking layer with Moya with more like 3, 4, 5 requests, you know how this can get pretty messy, right? So now it's just some boilerplate code that is generated. And just to make it complete, if you are using some sort of dependency injection framework, you have also the registration into the container generated. And if you would happen to be in a situation that you don't have yet set up the data source dependencies class, then you have that generated also. All right, so now we have the networking layer, right? And what we might be interested in then is to save these data retrieved from the server into a Realm database. But unfortunately, not like in the Android world, where we can store the data class onto which the API response is mapped immediately to SQL database, probably using a Room framework. In iOS, if we want to use Realm, we need to define a Realm object for this data persistence. And and in order to be able to convert those objects easily, or just basically handle them as if it would be one type, we want to define a bridging protocol. So we are not only duplicating information here, we are actually triplicating it, which is horrible, right? So let's generate that. And for this, we have this iOS bridging and bridged entities template set, and the input might look like this. So let's imagine we have product information retrieved from the server. And what I haven't talked about yet is for what are those rows buttons at the right side. Now, let's imagine that I've clicked this rows button in the price row and we get here. So yeah, you can create embedded submodels and yeah, basically infinitely. And make it as use it as a input for the generator. So yeah, that's the input. And if we generate, then as you can see, we have all the files we should need in order to persist the server data, the data retrieved from the server in a Realm database. And again, if you just go briefly through all the files, here we have the protocol, the bridging protocol for the submodel, API entity struct, codable struct for mapping the API response. Again, the same thing for price. And here we have the DB entity where some magic is happening, and we can see there are some irregularities that the generator can handle, as we can see with the properties, where the colors list can be marked with this Objective-C property wrapper and with the dynamic keyword. And also the same thing goes on in the initialization, where Again, here we see a similar irregularity. So that's one nice thing, but that's another nice thing about the generator is that it makes some thinking for you. So you don't have to be thinking about, oh, how was it that DB entity handles arrays? They can be arrays, they should be lists. Yeah, you don't need to think about it. Generator does it for you. And here we have the extension of the DB entity, making it conformant to the product entity. And here the same thing for price, and extension of the price DB entity, making it conformant to the price entity protocol. And if you are curious about the amount of white space there, there has been some subtemplates that hasn't been filled with any input, and they didn't clean up after themselves. But who cares? And of course, there are some required code in order to make it compilable immediately after the code is generated. All right. So now that we have quickly implemented a way how to get data from server and quickly implemented a way how to store the data in Realm database, we might be interested in displaying the data in a presentation layer. And yeah, as you can see, there is a lot of things going on, a lot of boilerplate code going on, and of course we don't need to write that anymore. And we can also generate code for both Android and iOS at the same time. So those are the things we are going to generate with our last example, and the input might look like this. The individual rows are representing the views contained in the view items and cells, the UI collection view cells. And basically, I hope this is, again, pretty self-explanatory what is specified here. If not, feel free to ask. And as you can see, the template set got quite big here, and the output is exactly what we expect. It should be basically everything we need in order to create this screen, or screen basically, with a UI collection view or a recycler view with all the things that are needed. And if you don't mind, I would rather not go through all the files because, well, there are some time constraints we should obey. But I would just like to point that there are also some syntactical options how to handle lists like this or like this. So as you can see, the 3 dots are really some sort of keyword here or operator that generator can use. And it can also handle things like this. And this is an implementation of a comparator function in Swift. So this should basically cover many cases of how you want the output to look like. All right. So how does this thing actually work? It seems like it can do anything. Yeah, of course it does. No, almost. And there are these 3 core concepts or aspects in the generator's processing. First, there is this configuration. Then there is this recursive template processing and placeholder specifiers evaluation. Sounds fancy? It's quite simple, as you will see now. The configuration consists of 5 options right now. Maybe some will be added in the future. The first two, header and row, are specifying how the UI, how the input should look like. Output folder name key just points towards a field after which the output folder should be named. Pretty easy. And the last 2 are seemingly a little more complex, but they are actually, again, quite easy, maybe except the last one. But all is explained, I hope, quite well in the manual you can get. So if I break it down, yeah. So let's remind ourselves how the iOS networking example looked like. And this UI has been configured like this. So this is the header field in the configuration. I hope all is pretty self-explanatory. And the IDs are used to, the generator used the IDs to decide which placeholder should be replaced with which value. So if there is networking type placeholder in the template, the value in the networking type field is used, and it replaces the placeholder in the template. And here is the configuration for the row or rows. And again, should be pretty self-explanatory. Just know that for the drop-down menu type, you need to provide a set of options from which the user needs to choose one. Then there is this rows only configuration, which basically lets you use some templates while they accept only rows as the input. This is how we get our spec files. And row rules, which do a similar thing, but have more flexibility along with a little bit more complexity. And again, all of this is explained in the manual. Right, so then there is this recursive template processing, which is quite simple in its core. The generator just replaces the values in the placeholders with values from the header fields, then replaces placeholders with values from rows. And if there are some unfilled placeholders, the generator loads subtemplates for them and repeats the process up to the point when there is no unfilled placeholder. And there are those placeholder specifiers, which makes it possible for the generator to decide when the input when the subtemplates content should be used or not. And let's go quickly through those. So if has, and if not, if has not, does a very simple thing, as we can see in the example placeholder. The interaction binding function subtemplate content is used if the row has interaction, which is a truthy value, either non-empty string, 1, or true. And yeah, 1 is just basically how Python actually represents the true value, so it's quite same thing. Yeah, so that's that. And if not, if has not, is just the negation of the former specifiers. Switch if provided. Again, as we can see in the example, the view type switch if provided custom type basically says use view type subtemplate content, and if there is custom type, oh sorry, no, view type is in this case is a row field. So place the view type there, and if custom type is provided, use that. Use that basically. So you can make this like nice decision process incorporated in the template itself. If some row has, again, very similar thing, but just checking all the rows. So here in the example, interaction binding extension should be placed in the output if some of the rows has interaction specified. And capitalized probably don't need much explanation, just put there the value from the field and make the first letter in uppercase. All right. So just to recap, there are these 3 core components of the generator's processing: the configuration that should match the templates, recursive template processing, and placeholder specifiers evaluation. And that's basically everything that makes the general generator so flexible and awesome. All right. Some advantages of GenGen are its domain and platform independence, because you can basically create templates for anything. Yeah, and you can scale it and extend it as you want. And one nice, quite of a side effect of this is that you can also encapsulate some knowledge inside the templates. Like, for example, the team reviews its conventions, finds that some conventions are have better implementation, or better, yeah, implementation is a good word. And then all that is needed in order to make those conventions prepared for every team member is just to change the template, and everybody is ready to go. Another example is that when new technology is learned by a team member, and the team member finds some sort of pattern in the API of the technology, then all that is needed then is to create a template, and everybody can use this new technology without much learning about technology. Well, that depends on how deep knowledge is needed in order to the technology to be used properly. But once it is encapsulated in the templates, then it makes the introduction into the technology and its usage more easier. And what's the future? Well, one of the points where we would like to get in the future is web-based UI, because now the tool is a standalone app written in Python, and it's not hard to have it running. You just need to follow a few simple steps that are included in the README. But web-based UI is something that would make it even more accessible, which would be awesome. And we would also like to include config and input checkings, because it would be nice if the user would be warned that there may be some wrong row or wrong part in the configuration or in the input. And yeah, other UX improvements are always nice. And we will probably add more specifiers and config options when we will see that they will be something that would add value to the generator. So to sum it up, as we have seen, code generation may save a lot of time. It can increase code quality by setting up nice conventions. It can lead to speeding up everything. And as we have seen in the ultimate answer, it just makes people happy. And first thing to start with this is setting up a proper mindset. Like, we don't really need to write anything twice. And once there is this proper mindset, then there is GenGen to help you with generation of anything. All right, so you can get all the resources at the Synatex CZ/mDevCamp 2020.zip, and you can get the GenGen itself at our GitLab repository at this address. All right, so I think this should be it. That's everything I had to say. So I only have now to, I have to emphasize that if you have some problem with the tool, you can always raise an issue in the GitLab repository, and I will do my best to make it work. Well, it's working now, but some crazy templates may run to some problems. So yeah, if any problem, raise an issue, and I will check that out. And if you would need any help, you can always check the manual, or you can always write me an email, and I'll be very happy to help you with that problem. And that's basically what I have to say. And I'd like to thank you for your attention.
Thank you very much, Tomáš. It was absolutely a pleasure to have you as a speaker. And now we have some questions. So we'll start with the first one. Is it possible to adapt the GenGen for another platform, for front-end Python projects or another ones? Would it be difficult?
It is absolutely possible to use it for any platform, and it's not. Should not be difficult. Basically, it's only about the difficulty of capturing the patterns in the templates you have to write for GenGen.
Thank you. Another one. Great presentation and project. Agree. What do you plan next with GenGen?
All right. Well, as I mentioned, web-based UI would be nice. Some UX improvements as config and input checking, and maybe some other options to make it even more flexible.
Okay, another one. Would it be possible to use GenGen if you decided to change the architecture of the app?
Definitely. Basically, the change with our architecture can go along with changing the templates, and also it might be one of the ways how the architecture can change in a very easy way, because just the templates would change. I hope that answers that.
Hopefully. Then we have another one, a bit longer. Hi, Tomáš, great speech. I really like your approach to code generation. Just want to clarify, does this basically mean that when using GenGen, all you need to write is the module-specific code? Have you ever used it in a real project?
Yes, we have used it quite extensively now in iOS project, and I try to create some templates also for Android to make the Android also up to speed. But we have used it in iOS project quite in quite a lot of instances now, and yeah, it can save a lot of time, especially in the presentation layer, where, as we've seen with the MVVM example, a lot of code can be generated in like a few minutes that would either take maybe even hours to write by hand.
Well, thank you for your question and for the answer, of course. Another one, what parts of the templates do you usually check into the version control?
Sorry, what was I have
What
the question covered. Yeah, can you
what
repeat, please?
what parts of the templates do you usually check into version control?
All right. On the public side, we check everything from the templates, and well, yeah, there is some. Of course, we have some private template sets, and from those we check nothing. But we will publish something in the future. But from the public template library, everything is there.
Okay, thank you. Another one, what language did you use to write GenGen?
The language was Python, which I love.
Another one from Pavel, did you try Sorcery? Can you quickly compare it with GenGen?
Definitely, Sorcerer is an amazing tool, and it works in a little different way than GenGen. It's more probably more iOS specific, and it is commonly used to handle some other types of boilerplate code. And to compare it with GenGen, like in more, let's say, when we use it, Sorcery basically handles the type of input, let's say, well, input is usually Swift code that needs to be regenerated with every change more quickly. And what I dare to say that GenGen has more scope, has more extensive scope of what it can generate. But Sorcerer is definitely an awesome tool, and I encourage everybody interested in code generation to try it and use it. And to be honest, Sorcery was a huge inspiration for GenGen, actually.
Great. Thank you for the question, also for the answer. I would say these three will be the last, otherwise we'll run out of time. So how does the GenGen affect build phase in an iOS project?
Well, GenGen itself or its processing isn't currently anyhow like incorporated in the build phases. So there is nothing, no build phase basically. GenGen runs as a standalone app, and the code that is generated just needs to be placed into the project. But since build phases were mentioned, we were also thinking about how some bits of GenGen's processing could be incorporated in the as a build phase, basically. So maybe there will be an update in that regard.
Great. So another one for Android development only. What do you think about templates feature included in Android Studio? You can use it very simply right in the Android Studio environment.
Definitely, live templates are awesome in Android Studio. Really, something that Xcode can be inspired with, and it can be used in many places. For example, as we have seen the example of defining the live data and its private mutable counterpart. This is really something, it's small, but a really nice thing that you can use live templates for, because there is like 3 or 4 instances of the same information that just have to be written once using the live template. So yeah, great tool.
Thank you. And another question, is there a list of ready-to-use templates?
Yes, all those examples that I have shown are currently a part of the project, of the open source project. So yes, basically yes.
Great. Thank you so much, Tomáš. This was
Thanks a lot.
absolutely amazing. Thank you for all your answers. Everyone asking questions, thank you for your questions. I definitely recommend to go and seek Tomáš in the 3D world and join him at the Speaker's Corner. He will be there at your service and for another 15 minutes at least. And I'm pretty sure he will answer all of your questions because I can see there's a lot of them. Then thank you very much, Tomáš, again for your talk. It was great, and I would
Thank
like
you.
to encourage you in the 3D world also to join our partners stand. If I can name them, the most our beloved partners is MSD, Microsoft, Bitrise, Kiwi.com, Showmax, TTC Teleport, and JetBrains. please go and visit them. Hunt Tomáš down in 3D World to ask him about GenGen. And we'll see each other very soon. And just a reminder, if you want to go and attend the after party, I highly recommend it. You need to download the latest version of the app. It was released around noon. It's the 9.2, I think. I don't want to lie. So don't forget to use that. Tweet with hashtag mDevCamp, and we'll see you in a bit. Tomáš, thank you very much.
Thank you too. It was awesome.
Thank you. Bye, guys.